Sensing terms. I'm just going to run through a few of the terms you need to be aware of when considering sensors. First, sensitivity. This is how much the output of a sensor changes for a given input. I'm going to illustrate this with a very simple case. Here we have the same volume of water in two different measuring cylinders. In this very simple case, the same volume of water, the input, added to the container on the right, gives a much bigger change in height, which is the output for a measuring cylinder. We can calculate sensitivity as the change in the output divided by the change in the input. If a potential divider circuit is used as a thermometer, it might give a 3 millivolt rise in potential difference for a 10 degrees C temperature rise. Its sensitivity, therefore, is the change in output, 3 millivolts, over the change in input, 10 degrees C, giving a sensitivity of 0.3 millivolts degrees C to the minus 1. Don't forget to quote the units. Resolution. This is the smallest change a sensor can detect. If you're using a digital display, a change smaller than that represented by the last digit cannot be resolved. Response time. This is how long a sensor takes to reach its final value. For example, here I have a graph of the output potential difference from three sensors which have been given some change. It could have been a change in temperature, for example. Sensor C responds very quickly and has reached its final output value by this point. Sensor A has reached its final output value by this point, but sensor B doesn't reach its final value to around this point. So the sensor with the longest response time is B.